For scientists, space is the initial fantastic ground. It is an unlimited source of knowledge and learning that's also assisting in the answer of some of the most fundamental existential concerns about the origins of Earth and our place in the universe. The human species has advanced enormously, and a result of its insatiable need to satisfy its natural curiosity. Beginning with our ancient ancestors' discovery of fire and continuing all the way to the current day with our forays into space, humankind has been driven to find new things out of both natural curiosity and a hope for a better future. Now scientists have made a very astonishing discovery. They have identified a single huge source in space that is transmitting a multitude of messages to us. However, what could it possibly be? Stay with us to the end of the video. There's a lot of information to be revealed. Do you have any experience with the term rapid radio burst, or FRB? Although it's some, it may appear to be an unremarkable phenomena. It has captivated astronomers, scientists, and space fans alike. Part of its allure rests in the fact that we still have a great deal to learn about it, which is one of the reasons for its enigmatic nature. Imagine the excitement that spread through the scientific community when it's discovered that scientists had picked up many FRB signals in a relatively short amount of time, and that the signals just kept coming. FRB is one of the most perplexing mysteries that can be found in space. It causes us to question what or who is trying to catch our attention and what they might possibly want from us. Space is home to many other mysteries as well. The FRBs are strong bursts of radio emissions that only endure for a few milliseconds but are extremely fleeting. They have a pulsar-like dispersion sweep that is characteristic of radio pulsars. The first known instance of an FRB was observed in 2007 by Dr. Duncan Lorimer. However, after examining archive data, researchers realized that the FRBs had been spotted around 6 years earlier inside a pulsar scan of the Magellanic Clouds. The fact that FRBs is also known as the Lorimer burst shouldn't come as a surprise to anyone. Researchers pay particular attention to characteristics called dispersion whenever FRBs are captured by telescopes. This characteristic quantifies how spread out an FRB gets by the time it gets to Earth. Plasma is a soup made up of charged particles and can be found throughout the enormous stretch of space that lies between galaxies and stars. This space is not empty but contains plasma. As it travels through space, light encounters a variety of impediments, each of which has the potential to alter its path. Plasma is one of these impediments and has the ability to slow down light and other electromagnetic waves, including radio frequencies. It is interesting to note that radio waves with lower frequencies are more strongly influenced and slow down much more than waves with higher frequencies. The dispersion effect is caused by the higher frequencies of fast radio bursts arriving on Earth before the lower frequencies do. These bursts consist of a series of different frequencies. Scientists make advantage of this dispersion in order to calculate the distance between Earth and the FRB source. When there is more dispersion, it indicates that the signal have traveled through more plasma, which indicates the source is further away. The initial FRBs that were discovered had appearance of gigantic pulses from radio pulsars, and their origin was determined to be close to a small Magellanic Cloud. But because of the limitations of the instrumentation at the time, the intensity of the signal was unable to be precisely quantified. The researchers think that the first FRB might happen in several hundred bursts each day, but there is just a minuscule possibility that it will be detected. After the initial FRB was found, scientists were under the impression that it was a one-of-a-kind occurrence due to the fact that it had only been observed in 3 of the multi-beam receivers, 13 beams. However, a student called Sarah Burke Spolar discovered another burst a few years later that had virtually the exact same dispersion as the Lorimer burst, which led to a resurgence of interest in the pitch. In 2013, Thornton & Company made a discovery of 4 additional Lorimer bursts that were later referred to as fast radio bursts. These bursts were discovered by using the Parkes 64-meter radio telescope to conduct high-time resolution universe surveys. In comparison to the original Lorimer burst, these bursts exhibited dispersion measurements that were substantially higher. The brightest bursts had a dispersion broadening with the power law dependencies, which is consistent with what we would anticipate seeing from radio emission sources coming from alien origin. The announcement of the first FRB discovery, made in another observatory, came in 2014. However, the origin of the object has remained a source of debate, and the researchers are still attempting to understand it. It is a perplexing riddle that experts are eager to unravel. And with developments in technology and study methodologies, we might just get closer to understanding these mystery bursts and where they came from. In the year 2019, researchers looked deep into their data, and they discovered an astounding discovery. The research showed that the FRB 121102 source produced a staggering 1,652 flares over the period of just 47 days, setting the record for the greatest number of flares ever found coming from an FRB. Researchers were forced to scramble to identify any kind of regularity or periodicity inside the bursts as a result of the new information, which opened up an altogether new universe of possibilities for them to investigate. Sadly, their efforts were fruitless because they were unable to identify any indicators that fit into any kind of pattern. The absence of periodicity presented a significant challenge for the researchers, as it made it very difficult to identify the origin of the bursts and caused them to scratch their heads. They were left with the question of whether these flares may be produced by more than one mechanism, and they acknowledged that it may be quite some time until we completely understand the secrets of FRBs. To make matters even more difficult, the vast majority of FRB sources only flare up once before disappearing, which makes it even more difficult for scientists to forecast or trace them. Only a small subset of FRBs is known to send out signals on regular basis, with FRB 121102 being one of the most active of these FRBs. This peculiar object has enabled researchers to trace it all the way to a dwarf galaxy located 3 billion light-years distant. Yet it is not a conventional FRB because it is extremely busy and follows a pattern that is all on its own. The amount of activity from FRB 121102 has given astronomers a chance to look at it when it's emitting, and it's one of the tools that has helped us with the 500-meter aperture spherical radio telescope, also known as FAST for short. Even during the testing phase of the telescope, it picked up FRBs. It goes through 90 days of activity and afterwards 67 days of silence. FAST gathered an incredible 59.5 hours worth of data over the course of 47 days in only 2 short months. The highest amount of activity that has ever been witnessed in an FRB source was seen during the peak rate, which was 122 bursts in just 1 hour. The researchers were able to conduct a statistical analysis of the actions of the sources since they had access to the enormous data haul. They divided the bursts into 2 groups, those with more energy and those with lower energy. These 2 groups showed substantial distinction in their attributes. For example, the weaker bursts were demonstrated to be more unexpected than their natural state. Even though most FRBs don't follow any predictable pattern, scientists are nevertheless determined to find out what causes them. They have found through their investigations that these bursts originate from galaxies that are really millions or even billions of light years away, but produce enough energy in a mere fraction of a second to power hundreds of millions of suns. This was found to be the case when they compared the distance between the galaxies to the speed of light. In recent times, the researchers have been successful in locating another fascinating FRB. This FRB stands out because it repeats itself more frequently than others, releasing 75 bursts in just 6 months. The team used the powerful, Very Large Array radio telescope located in New Mexico to focus on the FRB. And finally, they were successful in finding the source of this mysterious signal coming from such a dwarf galaxy located about 3 billion light-years away from us. FRB 190520 was detected by the FAST telescope in China. When the study team identified a feeble radio signal coming from the same location as FRB 190520, they made the startling revelation that it originated from that location. There's just one other FRB source that is known to exhibit this persistent signal, making it a unique discovery. The researchers were able to figure out how far away the object was from Earth by using the position of the dwarf galaxy that FRB 190520 originated from. Nevertheless, their findings uncovered a peculiar inconsistency. The estimated distance, which was based on the FRB's dispersion, was 30 billion light-years, which is 10 times more than the real distance, which is 3 billion light-years. This is a surprising and puzzling finding. It is important to note that just 19 of the approximately 800 FRBs detected have been tracked back to their origins, which enables accurate distance estimations. For the remainder of the sources, astronomers must rely on dispersions to assess the distance from Earth to the distance of objects in question. This new FRB has enthralled the scientific world despite the fact that it raises even more questions than it does answers. The method of dispersion that was utilized on this FRB was completely off the mark, in contrast to the other 19 FRBs, for which the distances between them were estimated with an accuracy that was comparable to all their actual locations. The fact that the mechanism responsible for the fast radio burst is responsible for the persistent radio signals has scientists baffled and unable to stop themselves from wondering why our persistent radio signals are becoming more common and whether or not the same mechanism is responsible for both. In addition, the team was taken aback by the extremely high dispersion rate of FRB 190520. With the help of many telescopes located in different parts of the world, the research team hopes to identify whether the FRB itself is responsible for the phenomenon or whether it was triggered by something in the immediate area. It is possible that in the future, as additional discoveries are made, we will eventually solve the enigma of what caused FRBs to form, which would pave a way for a deeper comprehension of these odd objects seen across the galaxy. In conclusion, rapid radio bursts are strange cosmic phenomena that have captivated the attention of both scientists and the general public. These bursts of radio waves come from an unknown source in the universe. We have reason to believe that with the application of cutting-edge technology and the combined effort of researchers from around the world, we will be able to learn more about these peculiar things and achieve a more profound comprehension of our cosmos. Thank you for watching. If you have any questions, let us know in the comments section. Also, at last, give this video a like. See you soon.